Start at the very beginning. What exactly is matter? Matter is anything that has mass and takes up space. That means everything you see around you, your desk, the air you breathe, even the water you drink is made of matter. From the tiniest grain of sand to the largest mountain, matter forms the foundation of our physical world. Understanding matter is essential because it helps us make sense of how things interact, change, and exist. In this video, we'll explore the different states of matter and their unique properties, setting the stage for a deeper dive into the science that shapes our everyday experiences. Matter commonly exists in three main states: solid, liquid, and gas. Each state has its own distinct characteristics and behaviors. Solids keep their shape, liquids flow and take the shape of their container, and gases spread out to fill any space available. These states are all around us, from the ice in your freezer to the steam rising from a hot cup of tea. By understanding these states, we can better appreciate the diversity and complexity of the material world. Let's take a closer look at each state and see what makes them unique. Solids are all about structure. The particles in a solid are packed closely together, often in a regular pattern, which gives solids their definite shape and volume. Think about a brick or a wooden block. No matter where you put them, their shape doesn't change. This rigidity comes from the strong forces holding the particles in place. Solids can be hard like metal or soft like clay, but they always resist changes in shape unless a force is applied. This property makes solids ideal for building and creating stable objects in our world. Liquids are fascinating because they flow and adapt to their surroundings. The particles in a liquid are close together but not as tightly packed as in solids, allowing them to move past one another. This movement gives liquids their ability to take the shape of any container while maintaining a constant volume. Water, juice, and oil are all examples of liquids. Whether you pour water into a glass or a bowl, it fills the space but doesn't expand beyond its volume. Liquids are essential for life and play a crucial role in countless natural and human-made processes. Gases are the most energetic of the three main states. Their particles are far apart and move rapidly in all directions. This freedom allows gases to expand and fill any container no matter its size or shape. Think about the air in a balloon or the steam from boiling water. Gases are everywhere, often invisible but always present. Because their particles are so spread out, gases can be compressed or expanded easily. This property is crucial in everything from inflating tires to breathing. Gases remind us that matter isn't always something we can see or touch directly. Beyond solids, liquids, and gases, there's a fourth state called plasma. Plasma is less familiar in our daily lives but is actually the most common state of matter in the universe. It's found in stars, lightning, and neon signs. In plasma, particles are so energetic that electrons break free from atoms, creating a soup of charged particles. This gives plasma unique properties like conducting electricity and responding to magnetic field. While we don't encounter plasma often on Earth, it's essential for understanding the cosmos and modern technology. Matter isn't stuck in one state forever. It can change from solid to liquid, liquid to gas, and even back again. These changes are called phase transitions. For example, when ice melts, it turns into water, a solid becoming a liquid. When water boils, it becomes steam, a liquid turning into a gas. These transitions happen because of changes in temperature or pressure, which affect how particles move and interact. Understanding phase transitions helps us explain everyday phenomena like why ice cubes disappear in a drink or how clouds form in the sky. Melting and freezing are two common phase transitions. When a solid absorbs enough heat, its particles gain energy and start to move more freely, turning into a liquid. This is melting. Conversely, when a liquid loses heat, its particles slow down and lock into place, becoming a solid. This is freezing. These processes are all around us, from ice cream melting on a hot day to water freezing into ice cubes. The temperatures at which these changes happen are called the melting and freezing points, and they're unique for every substance. Evaporation and condensation are key processes in the water cycle in many everyday situations. Evaporation occurs when particles at the surface of a liquid gain enough energy to become a gas, like water turning into vapor on a sunny day. Condensation is the reverse, when gas particles lose energy and come together to form a liquid, such as dew forming on grass in the morning. These changes are driven by temperature and pressure, and play a vital role in weather, cooking, and even breathing. Some substances can skip the liquid state entirely during phase changes. Sublimation is when a solid turns directly into a gas, like dry ice disappearing without melting. Deposition is the opposite, when a gas turns directly into a solid, such as frost forming on a cold window. These processes may seem unusual, but they're important in nature and industry. Sublimation is used in freeze-drying food, while deposition helps create beautiful frost patterns. These transitions remind us that matter can behave in surprising ways. To truly understand the states of matter, we need to look at the particle theory. This theory says that all matter is made up of tiny particles, atoms, and molecules that are always moving. The way these particles are arranged and how much they move determines whether a substance is a solid, liquid, or gas. In solids, particles vibrate in place. In liquids, they slide past each other. And in gases, they move freely. This simple idea explains a lot about why matter behaves the way it does. Every piece of matter has two fundamental properties: mass and volume. Mass is the amount of matter in an object, usually measured in grams or kilograms. Volume is the amount of space an object takes up, measured in liters or cubic centimeters. These properties help us describe and compare different materials. For example, a rock has more mass and volume than a feather. Understanding mass and volume is essential for everything from cooking recipes to building bridges. Density is a property that tells us how much mass is packed into a given volume. It's calculated by dividing mass by volume. Dense objects like metal feel heavy for their size, while less dense objects like wood feel lighter. Density explains why some things float and others sink. For example, oil floats on water because it's less dense. This property is crucial in science, engineering, and even cooking, helping us predict how materials will behave. Temperature and heat are key factors in changing the state of matter. Temperature measures how hot or cold something is, while heat is the energy transferred between objects because of a temperature difference. When you heat a solid, its particles move faster, which can cause it to melt. Cooling does the opposite, slowing particles down and causing freezing. Understanding temperature and heat helps us control and predict phase changes in everything from weather to cooking. Pressure is another important factor that affects the state of matter. Pressure is the force applied to a surface by the particles of matter. Increasing pressure can force particles closer together, sometimes causing gases to become liquids. For example, high pressure is used to liquefy gases for storage and transport. On the other hand, reducing pressure can make it easier for liquids to boil or solids to sublimate. Pressure plays a big role in everything from weather systems to industrial processes. Solubility is a property that describes how well a substance can dissolve in another. For example, sugar dissolves easily in water, but sand does not. Solubility depends on the nature of the substances and the temperature. This property is important in cooking, medicine, and environmental science. It helps explain why some drinks are sweet and clear while others are cloudy. Understanding solubility helps us mix and separate materials effectively. Conductivity is the ability of a material to transfer heat or electricity. Metals like copper are excellent conductors, which is why they're used in wires and cookware. Materials like rubber or glass are poor conductors, called insulators. Conductivity depends on how easily particles or electrons can move through a substance. This property is crucial in designing everything from electrical circuits to thermal blankets. It helps us stay safe and comfortable in our daily lives. Malleability and ductility are properties that describe how materials respond to force. Malleable materials, like gold, can be hammered into thin sheets without breaking. Ductile materials, like copper, can be stretched into wires. These properties are important in manufacturing and construction, allowing us to shape metals into useful forms. Not all materials are malleable or ductile. Brittle materials, like glass, break instead of bending. Understanding these properties helps us choose the right materials for different jobs. Hardness measures how resistant a material is to being scratched or dented. Diamonds are the hardest natural material, while chalk is much softer. Brittleness describes how easily a material breaks when force is applied. Glass is hard but brittle. It can scratch metal but shatters easily. These properties are important in choosing materials for tools, buildings, and everyday items. Hardness and brittleness help us understand why some things last longer or break more easily than others. Elasticity is the ability of a material to return to its original shape after being stretched or compressed. Rubber bands are a classic example. They stretch and snap back. Flexibility is the ability to bend without breaking, like a plastic straw. These properties are important in designing products that need to move or absorb energy, such as sports equipment or car parts. Elasticity and flexibility help materials withstand repeated use and stress. Viscosity is a property that describes how easily a liquid flows. Honey has high viscosity, it pours slowly. Water has low viscosity, it flows quickly. Viscosity depends on the size and attraction of particles in a liquid. This property is important in cooking, manufacturing, and even in our bodies, where blood viscosity affects circulation. Understanding viscosity helps us control and predict how liquids behave in different situations. Transparency is the ability of a material to let light pass through. Glass is transparent, allowing us to see clearly through windows. Opacity is the opposite. Materials like wood or metal block light completely. Some materials are translucent, letting some light through but not enough to see clearly. These properties are important in everything from architecture to packaging, helping us control light and privacy in our environments. Magnetism is a property that allows certain materials to attract or repel each other. Magnets are made from materials like iron, nickel, or cobalt. This property is used in everything from compasses to electric motors. Magnetism is caused by the movement of electrons within atoms, creating magnetic fields. Understanding magnetism helps us harness energy, navigate, and develop new technologies. Chemical properties describe how a substance reacts with other substances. For example, iron rusts when it reacts with oxygen and wood burns when exposed to fire. These properties determine how materials change during chemical reactions, forming new substances. Chemical properties are essential in chemistry, cooking, and industry, helping us create new materials and understand natural processes. Physical properties are characteristics that can be observed or measured without changing the substance itself. These include color, odor, melting point, boiling point, and density. Physical properties help us identify and classify materials. For example, gold is yellow and shiny while copper is reddish-brown. Understanding physical properties is essential for science, engineering, and everyday life. Matter can be combined in different ways to form mixtures and solutions. A mixture is a combination of two or more substances that keep their own properties, like sand and salt. A solution is a special type of mixture where one substance dissolves in another, like sugar and water. These combinations are everywhere, from the air we breathe to the food we eat. Understanding mixtures and solutions helps us separate and create new material. Pure substances are made of only one type of particle, like distilled water or pure gold. Mixtures contain two or more different particles, like air or salad. Pure substances have consistent properties, while mixtures can vary. This distinction is important in chemistry and industry, helping us create materials with specific qualities. Knowing the difference helps us purify substances and design new products. All matter is made up of atoms, the smallest units of elements. Atoms can join together to form molecules, which make up compounds and materials. For example, a water molecule is made of 2 hydrogen atoms and 1 oxygen atom. Understanding atoms and molecules helps us explain the properties and behaviors of different substances, from the air we breathe to the food we eat. Solids can be divided into crystalline and amorphous types. Crystalline solids like salt or diamonds have particles arranged in a regular repeating pattern. Amorphous solids like glass or plastic have particles arranged randomly. This difference affects their properties. Crystalline solids have sharp melting points, while amorphous solids soften over a range of temperatures. Understanding these types helps us choose materials for different uses. Surface tension is a property of liquids that makes their surface behave like a stretched elastic sheet. It's why water forms droplets and why some insects can walk on water. Surface tension is caused by the attraction between particles at the surface of a liquid. This property is important in nature, technology, and even in our bodies, affecting everything from raindrops to medical devices. Fusion is the process where particles spread out from an area of high concentration to low concentration. It's why the smell of perfume spreads across a room or why sugar dissolves evenly in tea. Diffusion happens in gases, liquids, and even solids. This process is essential in biology, chemistry, and everyday life, helping materials mix and move naturally. When matter is heated, it usually expands. Particles move faster and spread apart. When cooled, it contracts. Particles slow down and come closer together. This expansion and contraction can cause bridges to stretch in summer and shrink in winter, or glass to crack if heated too quickly. Understanding this property helps engineers design safe structures and products that can handle temperature changes. Buoyancy is the ability of an object to float in a fluid like a boat on water. It depends on the density of the object compared to the fluid. If the object is less dense, it floats. If more dense, it sinks. Buoyancy is essential in designing ships, submarines, and even hot air balloons. Understanding buoyancy helps us explore and use water and air effectively. We encounter different states of matter every day. Ice cubes in a drink, steam from a kettle, and the air we breathe are all examples. Understanding the states and properties of matter helps us make sense of cooking, cleaning, weather, and even breathing. It's a reminder that science is all around us, shaping our experiences and the world we live in. Matter behaves differently in space and on other planets. For example, extreme temperatures and pressures can create exotic states like superfluids or Bose-Einstein condensates. These states are rare on Earth but common in the universe. Studying them helps scientists understand stars, black holes, and the origins of the cosmos. It's a reminder that the states of matter go far beyond what we see every day. Properties of matter are crucial in technology. From the metals in your phone to the gases in light bulbs, understanding states and properties helps engineers design better products. For example, liquid crystals are used in screens, and superconductors rely on special states of matter. Technology advances by harnessing the unique behaviors of different materials. Nature is full of examples of matter-changing states. Water cycles through solid, liquid, and gas forms in rivers, clouds, and snow. Rocks melt into lava and cool into solid stone. Even living things rely on these changes. Plants absorb water, animals breathe air, and all life depends on the movement of matter. Observing nature helps us see the importance of states and properties in the world around us. Industries use the states and properties of matter to create products and solve problems. For example, steel is melted and shaped in factories, gases are compressed for storage, and liquids are mixed to make medicines. Understanding how matter behaves helps industries operate safely and efficiently, producing everything from cars to computers. Our bodies rely on the states and properties of matter. Blood flows as a liquid, bones are solid, and we breathe in gases. Chemical reactions in our cells depend on the movement and mixing of particles. Understanding matter helps doctors, scientists, and engineers develop better treatments and technologies for health and wellness. Artists and designers use the properties of matter to create beautiful and functional works. Paints, clays, metals, and glass all behave differently depending on their state. Understanding how materials change and interact helps artists shape their creations and bring ideas to life. Art and science come together through the states and properties of matter. Cooking is full of changes in the state of matter. Water boils, chocolate melts, and dough rises as gases form. Chefs use heat, pressure, and mixing to transform ingredients. Understanding the science behind these changes helps us cook better and enjoy delicious meals. The kitchen is a laboratory where the states and properties of matter come to life. Weather and climate are driven by changes in the state of matter. Water evaporates to form clouds, condenses to make rain, and freezes into snow. These changes shape our environment and affect everything from agriculture to transportation. Meteorologists study the states and properties of matter to predict weather and understand climate change. Science experiments often explore the states and properties of matter. From growing crystals to making slime, students and scientists learn by observing how materials change. Experiments help us test ideas, discover new properties, and develop new technologies. The laboratory is a place where curiosity and knowledge come together through the study of matter. Scientists are constantly discovering new states and properties of matter. Research into nanomaterials, superconductors, and quantum states is opening up new possibilities for technology and medicine. The future of matter research promises exciting advances, from faster computers to new materials that can heal themselves. Staying curious and exploring matter will continue to shape our world. Wrap-up matter is all around us, existing in different states and showing a wide range of properties. From the air we breathe to the devices we use, understanding matter helps us make sense of the world and improve our lives. Whether you're a scientist, artist, or just curious, exploring the states and properties of matter opens up a universe of discovery. Thanks for joining us on this journey through the amazing world of matter.